acidity and pH. So pH we've learned all about, and we know that it relates to acids and bases, but what pH actually is relating to is to the concentration of hydrogen ions in the solution. And it's from the formula pH equals negative log 10 of the concentration of H plus ions, which of course can be written as hydronium, because these H plus ions straight away pair up with water molecules to make hydronium. So it's the negative log 10 of H3O positive hydronium. This formula can be rearranged to look like this. So you can work out the concentration of hydronium ions if you know the pH. So the logarithmic scale, you don't need to be a mathematician to understand this, but I just want to show you that as you increase a pH unit, you are 10 times or tenfold increase in the concentration of hydrogen ion. And it looks something like this. So if we look at the concentration here of hydrochloric acid, you'll see that when it's a 0.1 concentration, it has a pH of 1. Yet when the concentration is a lot lower, the pH increases and becomes 5. So this is an inverse relationship. As you decrease the concentration, you increase the pH. And that makes sense because the higher concentration acids have a lower pH. And you can see here, the more acidic an acid is, the lower the pH will be. And just to note at this point, pH can actually be negative, so it can go down to 0 or below 0. And of course, bases are anything from 7 and above. So, how do we use this? An example question is that you need to state the pH of a solution given that the concentration of H plus is 0.0001 molar. So, we use this formula here that pH equals negative log 10 hydronium. We pop in this figure here, which is the hydronium concentration, and we solve to get a pH of 4. The other way that the question can ask is what is the hydrogen concentration of a solution with a pH of 5.2. So then we use the other formula where hydronium equals 10 to the negative pH. We pop the pH in there, so we solve for this and we get 6.31 by 10 to the negative 6 molar. So here's two questions for you to have a go at. So state the pH if the hydrogen concentration is measured to be 0.1 molar and if the hydrogen concentration is 0.000001 molar. Pause this, have a go, and I'll pop the answers up. So the answer to the first one, pH equals 1, and the answer to the second one, pH equals 6. Another question for you to have a go at. Again, pause it and see how you go. So for F, the answer is 10 to the negative 7 molar, and for G, the answer is 6.3 by 10 to the negative 5 molar. Remember, you need to work out this indice. You can't leave this in this form. So another example of a question is that you might be asked to find the pH of a acid solution. So you need to think about the acid, whether it's monoprotic, diprotic, or triprotic. This is hydrochloric acid, so it's monoprotic. So this in water will form one hydrogen ion. So we know that the hydronium concentration will be equal to the concentration of the acid because only one hydrogen is being formed. So we can now plug that into our formula and solve for the pH, which is 3.0. If you've got a diprotic acid, you need to take into account that it will produce 2 hydrogen ions. Sulfuric acid will ionize, and this will ionize again to produce those 2 hydrogen ions. So we know that the concentration will be twice this amount because each of these sulfuric acids will produce 2 of the hydrogen ion. So we multiply the concentration by 2 and then we just solve using this formula again. So plug the concentration in here and you'll get a pH of 2.7. So here's 2 for you to have a go at. Again, pause this and see how you go. So the answers, pH equals 2, and for the second one, pH equals 1.52. Remember, this is a triprotic acid, so it will produce 3 hydrogen ions. I've got the work solutions for this at the end of the video if you're confused. Need to watch any more? I'm going to go through the work solutions on those couple of questions. So question 10 was find the pH of a 0.01 molar nitric acid solution. So it's simply a case of this is the same concentration. It's a monoprotic acid, so there's only one hydrogen ion. So the hydronium concentration will be equal to the concentration of the nitric acid. Plug it into this formula, and if you put this in your calculator, you'll get a pH equals 2.0. Phosphoric acid, however, is a triprotic acid, so thus each one will produce 3 hydrogen ions. So to find the hydronium concentration, you need to multiply the concentration of phosphoric acid by 3. So you get a concentration of hydronium of 0.03 molar. Then just pop this into your pH equals negative log 10 H3O positive, and you'll get an answer of a pH of 1.52.